Hello guys, I'm Ajman and today I'll be explaining the additional mathematics paper 1 solution. So in our first question we have that x plus 5 is a factor of p where p is this expression. So p is a cubic expression which has a variable a in it, and then when p of x is divided by x plus 1 the remainder is b. So first we need to show that a is equal to minus 24 and then find the value of the constant b. So for the first part, since we know that x plus 5 is a factor, so using the factor theorem, we can know that p of x plus 5 means x is equals to minus 5, and if we set this minus 5 into the function, we should get 0 since x plus 5 is a factor of this expression. So using the theorem, we do this, we set it to minus 5, and then we set it to 0, and then since it's a one variable one equation, we can simply solve for a and we get minus 24, and then we need to find the value of the constant b. So this part we use a remainder theorem. So we are asked p of x when it is divided by x plus 1 the remainder is b. So what we do, we simply this time set x to minus 1. So x equals to minus 1, x equals to minus 1. So we set x so p of a minus 1, so so this is the p of minus 1, and then we simply solve it and we get the remainder. So that's it. Then we are asked to factorize p of x completely and hence state all solutions of p of x equals to 0. So to factorize this completely, first we don't know how to factorize a cubic expression, right? So that's why we first divide it by the factor we know. We know that x plus 5 is a factor from the first part. So we divide the differential expression with x plus 5, and then we get this as the quotient and a remainder of 0. So then the cubic expression can be broken down into x plus 5 into this expression. So and also this expression is a quadratic, and we know how to break down quadratic. We can use middle term breaking. So that's what we do, we break down this quadratic into this. So 3x plus 2 into x minus 1. So these are the three factors: x plus 1, 3x plus 2, and x minus 2. So that means this is how we can so this is p of x fully factorized, and then when we set it to equals to 0 we can find the value of all the x's. So we set this expression to 0, and then one by one we just so let's say for this part we take all these other terms to the right, so they become x plus 5 into 0 by all this. So we're left with x plus 5 equals to 0 and we get x equals to minus 5. Like this we find the three values of x, and these are the solution. So this is a very straightforward question. Over here we are given two expressions and we are told to differentiate them. So for the first one, it's a product of two functions, right? So we can ignore the 5 since it's constant, and we have x square 1x1 function, another one is tan x. So two functions. So we use the product rule, which is u v naught plus v u naught, or another way you can write it is dy by dx is equals to, so du by, okay, so following this expression we just simply write u. So du dv by dx plus v du by dx. Both mean the same thing. So we simply do that. We set u is equals to 5x square and v is equals to tan x. We could have taken 5 separately and done it, or it doesn't really matter, or just add it to one of the expressions. So that's what they did here. So differentiation of u is u prime, which is 10x, and the differentiation of v is 6 square x. And now you just simply input them into the formula and then simplify, and that's it. And for the next expression we can see there are two functions, and it's one in the numerator and then is in the denominator. So we can use the quotient rule here. So the quotient rule is given here: v u prime minus u v prime by v square. So again we set u to the first expression, so 6 7x plus 2, and v is equals to the denominator, which is x cubed plus 2. Then we differentiate, and this becomes 7 6 are 42 e to the power 7x plus 2, and v prime is 3x square. And now you just simply input this into the required place in the equation, in the formula, and then simplify. So over here we have 6x e to the power of 7x plus 2 common, and we take it out common, and then we simplify to this. Other answers are also acceptable. So over here we have an expression 2x squared plus 12x minus 5, and they want us to write it in this form. So it's a quadratic, we want to write it in this form, which is the combinatoric square form. So it's a combinatoric square question basically. So how do we do this? We first take 2 common from the entire thing because we want to single out x square, not the entire thing. We can just ignore the plus c. So 2x square minus 6x and then the minus 5. So and then we the combinatoric square formula. So we basically just x and half of this, which is minus 3 square, and we will have plus 9 extra, right? So we subtract the 3 square, then the plus 9 is in like 3 square extra, so we subtract the 3 square and then we minus 5 here. So this becomes 2x minus 3 square minus 9 into is 18, so minus 18 minus 5 is 23. So yeah, that's it. And then they want us to graph the modulus of this expression. So what do they want? Show the minimum and the maximum points and the y-intercept. So y-intercept, so find the y-intercept, we need to set x equals to 0. So let us do that. We set x equals to 0 and we have the expression from here directly. So it's just minus 5, the c, the y-intercept of this equation. And then literally modulus, right? Modulus means everything will become positive. So this becomes 5. So the y-intercept will be here at 5. Next, we are asked to show the minimum and maximum point. So this is a minimum curve, right? Because of since the x square is positive, it means it's a minimum curve. So and the minimum point is minus 23, and it happens that x equals to 3. Sorry, minus 3, since we want to turn this into 0. So it minus 3 minus 23 is the minimum point. But remember, everything becomes positive, right? So this minus 23 will become 23. So 23 will become the maximum point actually, like here 23. And so now we just simply draw the curve. So we draw the curve, and these points will be so these points will are the roots. So since this question's roots are imaginary, we don't have to find them out. So and we have the maximum point here and minus 3. So yeah, that's it. So first we simply draw the curve like this, and then we take everything that's below the x-axis and we just mirror it. Yeah, so that's it. So for the next part, we are asked state the set of values of x for which state the set of values of k for which this expression has exactly 4 solutions. So this expression equals to k has exactly 4 solutions. So when does that happen? We can see over here that if we draw a line here, there are 4 solutions. 1, 2, 3, 4. There is only 2 solutions here, and there are no solutions below this. And exactly at this point, there are only 2 solutions. So and the last part and this point here has exactly 3 solutions, right? So our maximum range is this. That means 23, because everything below has 4 solutions, and the minimum range is 0. Since at 0 there are only 2 solutions, and everything above has 4. So that's it. So our range is from 0 to 23. So in this question, we are given a function y equals to this. So y equals to this, where x is measured in degrees. State the period of y. So over here we're given a frequency of 12, right? So we simply divide 360 by 12 to get the period, so which is 30. And the amplitude of y. So amplitude is simply this number, this value over 15. And so find the equation of the curve in the form y equals to. So they want us to find the equation of the curve. So first, notice the amplitude. Amplitude is from 7 to 12, right? So it's 12 minus 7. The amplitude is 5. So 5. And what is this function? It starts from 7, but we can see it's a sinusoidal curve because it goes like this instead of like this, right? So it's sine. And then b. So b is the frequency. How many times are we seeing? How many cycles are there in 360? 1, 2, 3, 4. So there's a frequency of 4. So 4x, and then on a plus c, it's the intercept is 7. So it's simply 7. So yeah, that's it. So in this question, we have a particle that's projected from origin O, so that it moves in a straight line. At time t seconds after the projection, the velocity of the particle is given by this expression. And we need to find the time at which p first comes to instantaneous rest. So since it's in the velocity formula and we need to find it when it comes into instantaneous rest, we simply set it to 0. So we set the equation to 0, and then using middle term breaking, we find the 2 values. But over here we have 2 answers, right? When it says first comes to instantaneous rest, So and also t starts from 0. So since we are seeing at t seconds after the projection, so over here we have -5. Even though it's lower, it's still before the projection, right? At t equals to 5, the particle was not even projected, so this doesn't really count in this question. So the answer is only t equals to 7. In the next part, find an expression for displacement of p from after t seconds. Okay, so we have velocity, right? And we need to find the displacement. So what do? We just integrate, simply put. So we integrate this, and then so t seconds, right? So one thing is we have a plus c extra after integrating. So also we know that the particle is projected at t equals to 0. So at that point, if it's projected at that point, that means there was no displacement, right? So at that point the s is 0. So we simply set s equals to 0 and t equals to 0 to find the value of c. And using this we find the c is equals to 0. So that means we can just ignore the c, and the expression is just whatever we integrated. So next part is find the acceleration when t equals to 3. So since we have a velocity formula and we need to find acceleration when t equals to 3, we simply differentiate. So we differentiate this expression, 2t square minus 4t minus 70, and we get this, and then we can put t equals to 3 to get the acceleration at that time point, which we get as 8. So in this question we are asked to just simply integrate this. So we use the exponential addition rule. So if you have something like ax plus b, to integrate this we simply take the derivative of this part, so which is a, and divide here, and then we keep this as it is. So ax plus b. So that's what we do. We have 5 here, right? So we divide the inter expression by 5. 5 is the a, and we keep everything as it is, and then add a plus c. So that's it. Then find the exact value of, so over here we're given the limits, so we simply take this expression and then put the limits 4 and 1, and then we simply subtract, and we get the answer. Since it says exact value, we just keep it in the form with e. So next part, integrate this expression. So we don't so to integrate this, we can simply just open the bracket, right, to make things simpler. So we open the bracket and we can just use power rule again and again. So we use the power rule 3 times to do each of these separately, and then add a plus c, and then lastly we just simply simplify this part. So over here we have a particle p that is moving with velocity 10 meter per second in the same direction as this. So basically we have the magnitude of the velocity and the direction. So what do? We first find the magnitude of this. Since this thing has a magnitude and we know 10, right? We could simply multiply the direction and the velocity, right? But that wouldn't work because the direction also has its own magnitude, which is different. So if you multiply this, we'll get something that's higher than 10. So what we do, we find the unit vector. So to find the unit vector, we first find the magnitude of this expression, which is we just simply square both of the term and then square root it. So which we get is to be 5. Then we divide this expression, so it's written in this form, by 5 to get the unit vector, and then we multiply it by 10. You can check this by finding the magnitude of this, which you will find to be 10. So this thing has the magnitude of 10 and the same direction and vector as this. The next part, at time t equals 0, the p has position vector this related to a fixed point O. Write down the position vector of p after t seconds. So it has a fixed position of starting position of 3, 8, and then we add t. So this is the direction. So it's p, right? Same direction as this, right? So we just simply write this minus 8, 6. So that is the equation of this vector, and they simply got them together. So 3 minus 80 and 8 plus 60, and they also wrote it in the ij form instead. So it's the same thing. So moving on, the next part, a particle q has this position vector and has this velocity vector. Again, we can find out the equation using the point and the direction. Given that p and q collide, find the value of p when they collide and the position vector of the point of collision. Okay. So firstly, these two particles will collide, right? And so when they collide, the x, the y's, that will be the same. Both of the x's will be the same and both of the y's will be the same. But before that, we need to find out the equation of the vector q. So to do that, we do the same thing we did here. So firstly starts at 2, 2, and then we use a different parameter. So we use has a velocity vector of -7, 12. we're not going to use a separate vector. So since it is a velocity vector, it follows the same rules. We just use t. So over here, we simply now equate these two equations. So these two equations, we simply equate them. X and the y should be the same, right? So 3 minus 80 will be equals to 2 minus 70. So that's what we do, and then we find the value of t solving this. We could also do it for y. We will get the same value. If we didn't, they would not have been colliding. So we get the same value of, we should get the same value of 1. So find the value of t and find the position vector of the point of collision. Now we also need to find the position vector of the collision. So we simply take the 1 and input it into the vector again. So it could be either this or this, doesn't really matter. Both will get the same answer. We will get minus 5 plus 14 j. So over here we have a curve with this equation and a straight line with this equation. So this is the straight line and this is the curve intersecting at points P and Q. Showing earlier, we can find the area of the shaded. So we need to find the area of this. So before that, we need to find out we need to know the limits, right, of the so basically this is basically an integration question. We integrate the straight line and remove the curve from it. But in order to do that, we need the limits. So how to get the limit? These are simply the intersection points of these two lines. So we simply equate them. So that that's what they did here. This is basically the same thing as equating them. So what they did here is 2x square minus 3x plus 1 equals to x plus 7. They just subtracted each other and set it to 0 because they are the same point. Same thing, just equate them and then solve for x, and we get the two values, x equals to 3 and x equals to minus 1. So these are the two values, 3 and minus 1. And then we also they did this like so over here x plus 7. So what they did is, so over here they took this line x plus 7 and then subtracted this line minus 2x square minus 3x and then integrated over p to q. So minus 1 3. So this is the same thing as doing it separately. Normally you do it like this. So x plus 7 integrate minus 1 to 3 to get this entire area. So this whole thing, and then you subtract this expression 2x square. So let me just write y here, y dx minus 1 3, and then you will subtract, you will use this will give you this part. Another curve, you subtract it. So this can alternatively be done like this also. We are simply subtracting because both options are the same. We can simply get them together to make it like this, x plus 7 minus. I'm just writing y to represent this part and dx. So same thing. So over here we integrated, and then finally we solved it and got 64 by 3. So over here we have the line y equals to minus kx plus 3, where k is a positive constant and is tangent to the curve y equals to 2x squared plus 5 at the point A. Find the exact value of k. So we have a curve like this, let's say something like this, and there is a certain point where this line is tangent. So okay, this is a bad example. Okay, so this is like exactly touches at one point. So it touches just here. Okay, so how would we find this point? We simply equate them, right? So we equated them, but then there are two variables, x and k. We know it's tangent, right? So this, we know that this, since it's tangent, there is only one solution, and this can be rearranged to a quadratic. So let's do that first. 2x square minus kx plus kx and plus 2 equals to 0. So we can rearrange this to quadratic, and we know there's only one solution. That, what does that mean? That means the discriminant is 0, or b square minus 4 is equals to 0. So we put the values and then we get the value of k. Okay, the next part, find the coordinates of k. Okay, so now since we know the coordinate of k, we can simply input this into this equation and finally actually solve it this time. So we get x is equals to minus 1. So the coordinates, and then you input the x equals to minus 1 into this equation or this, doesn't matter, both of them should give us 7, given that we are using this exact k. Okay, so the next part, they ask us to find the equation of the normal to the curve at point A. So the normal to the point, so normal of the curve at point A, right? So since we already know that since we already know the tangent value, so that point is tangent at this point, and since they want us to find a normal, they want something like this, right? And the so it's perpendicular to the tangent. So if the tangent's gradient is minus 4, the perpendicular gradient should be 1 by 4. Since 1 minus 4 into m is equals to minus 1, that means m is equals to 1 by 4. And we need the exact point, right? We already have the point. So x minus 1, so plus 1, and y minus 7 equals to this. So yeah, that's it. We can simply further simplify and find the answer. So that is exactly what they do here. Yeah, they just kept it in this form. Doesn't really matter. Either works. So in this question, we have 7 people are to be chosen to receive concert tickets from a group of 6 men and 5 women. So find the number of different ways the 7 people can be chosen if 4 of them are men and 3 of them are women. So this is very easy. So first question, so the first part, we have 6 men, right? So 6 men among them, 4, 4 of them are men, right? So we have to choose 4 men. So 64 into, and among 5 women, we have to choose 3. So yeah, that's it. We just need to multiply them. And the next part, the group of 6 men and 5 women contains a man and his wife. Find the number of different ways 7 people can be chosen if both man and his wife are chosen or neither are chosen. So we have a total of how many people? 6 plus 5, 11 people. So among them, we have 2 cases. We either chose them or we didn't choose them. So let's say we chose them. All right. So we already chose them. So among the 7, we already took 2, and so we are left to choose 5 people, right? So also, since 11 minus 2 is also 9, we already chose them, right? 2 people, so we're left with 9 choices. So we have 9 choices and 9 people to choose from, and among them we will choose 5. Okay, so that is one case. We chose both of them, and if we didn't, we have all 7 people to choose, right? So 7 people to choose, and also we didn't choose them, right, among the 11, so we still don't count them. So 9 here again. So we simply add the 2 cases. So over here we chose them, over here we didn't choose them. So the next part. So Freddy has forgotten the 4-digit code he uses to lock his briefcase. So 4-digit code. 4-digit code. So he knows that he did not repeat any digit, and he uses numbers only 0 to 6. That he did not start with his code with a 0. Okay, so we have 7 numbers to choose from, 0 to 6. So 7 numbers, and he didn't start with 0, right? So first number he didn't choose 0. So 1 to 6, but he has 6 options. And since no digit repeat, we among the 7 we already chose one number, so we're left with only 6 options remaining, because since this can be 0 again, so that option is added back. And now we have 5 options again, 2 options gone, and then 4. So 4-digit number, right? So this is all. So we just really multiply and get 720. Now Freddy also remembered that his 4-digit code is divisible by 5. Find the number of different 4-digit numbers he could have chosen. So now it's divisible by 5. When it can be divisible by 5? If we have 5 at the end or 0, right? And that's both of these cases are possible. So let us say the last digit is 0. So we chose 0. We have only one option. And then the first digit we have 6 options, right? 1 to 6. So we have 6 options. Second digit we chose 2 numbers already, so 5 options. And the third digit, third digit we have 4 options. All right, so this is if we chose 0, ends with 0. And if it's end with 5, we already chose 5, so 5. And at the beginning we have taken out 5, and we cannot choose 0, right? So we have 5 options remaining among 7. We already chose 5, and we cannot choose 0, so 5 options remaining. And now we can again choose 5 here. It's fine. So we have 5 options total because we already chose 2 numbers only. And so out of 7, so 5 options remaining, and lastly 4 options remaining, so since we already chose 3 numbers. And then we simply add these 2 cases. So the next part, so Freddy decides to choose a new 4-digit code. A new 4-digit code for his briefcase once he has opened it. He plans to have the 4-digit number divisible by 2 and greater than 4000, again with no repetition of digits. Find the number of 4-digit numbers he can choose. So over here he has available all these numbers, again just 0 to 6, 7 numbers, and he can divisible by 2, right? When can he divisible by 2? If the number ends with 0, 2, 4, 6. We don't choose 8 because the maximum number is 6. And greater than 4000. Greater than 4000 means the first digit has to be 4, 5, or 6. We have these 3 options. So these are the first digits and the last digit. It's written over here like this again. So if the first digit is even, so we have chosen to these 2 cases, 4, 6 together, group them, because these 2 are the only options that's in both of them, right? So they can be grouped. You can do this separately. We can choose 3 cases that the first digit is 4 or 5 or 6, or we could to these two cases, it's faster, but either works. So if we say if we take these two cases together, so first digit is 4 or 6, so we have two options. All right, 4 or 6, and the last digit, since we already took one of them, we are left with either 4 or 6, and 2 and 3, so we're left with three options. And then we choose the middle term, so we already chose two numbers, but the middle numbers can be anything. So out of 7, two numbers are gone, we are left with 5, so 5, and then again 4 numbers remaining. So now if we chose the first digit to be 5, so that's 5, right? Only one option. And now since we didn't take any of the numbers from here, we are left with all four options. So we took two numbers already, so we have 5 options here, and lastly just 4 options. So yeah, that's it. We multiply these are the two cases, and then we simply add them together. So yeah, that's it. Another way you could have done is we could have just broken these two into another case. So it would have been like, let's say the first is 4 into, and the last is 4 is out, we have three numbers remaining, so 3 into, and we have 5 options remaining, so we took 2 and 4. And then this would have been the same thing if we took 6 as the first number, so 6 into, and last option again 6 is taken, so 0 4 2, so 3 options remaining, and 5 and 4. And then we add this. Notice that these two are the same, right? So basically this is multiplying by 2, so these are the same thing. And again, just breaking it even further, both methods work. This question is very difficult, so we shall do it from scratch. So over here we have the curve y equals to x into 15 into, minus x squared, so this curve over here, and the line y equals to 3x, so this line intersecting an origin O and the point R. The point P lies on the line y equals to 3x, so point P is in this line, and between O and R the x-coordinate of P is t, so the x-coordinate of P is t, and point Q lies on the curve, and PQ is parallel to x, so the x value of Q is also t. So given that t can vary, find the maximum value of the length of PQ. So we do find the maximum value of the length of PQ. So to do that, we first find out an equation for PQ. So how do we do that? We first find the point P and Q. So point P, we know the x value is t, and we simply put the t into 3x, we get 3t. So that's P, and Q is again t, since the t x values are the same, and the y value is we simply input t and simplify, so we get minus t cube plus 15t. All right, now the length of this PQ, what do? We use the square root for the distance formula, distance PQ formula. So PQ is using the distance formula, x1 minus x2, so xx minus, so t minus t whole square plus 3t, okay, just write minus t cube, minus t cube plus 15t, so y1 minus y2, so 3t whole square. So this part tt is 0, right? So t minus t, so this is a 0, and square root and on square, right, they cut off each other, so we're left with only this. So this simplifies to minus t cube plus 12t. So that is the equation of PQ, and we want to find the maximum value, right? So what do? We differentiate and equal to 0. So that's how we will know that. That's how we for optimization problem, we differentiate and equal to 0 to find the maximum value, right? So we just differentiate PQ. So PQ's derivative is minus 3d square plus 12 and equal to 0 to get the maximum value, and this becomes minus 3d square equals to minus 12 minus and then 4, this becomes 4, and t is equals to plus minus 2. So if we input that into this equation, into the PQ equation, so let's see what we get. We input plus 2, we get minus 8 plus 24, which is 16. And if you put minus 2, we get minus becomes plus, so plus 8 and minus 24, and this becomes minus 16. So this is obviously higher, right? So we simply use this form. Also, you actually notice that we eventually like modulus everything, right? Since it's squared actually in the actual formula, so this would have been squared, so there would have been the same thing, 16. So 16 is the answer. For the next part, this part is so let L be the normal to the curve. So L is normal to the curve at point Q. So at point Q, there's a line L which is normal to the curve. Imagine this goes actually to the Q. Okay, at Q where x is equals to 2. So x is equals to 2, and then this normal intersects the x-axis is point S. So x-axis is point S, and the y-axis at T. Find the equation of the circle that passes through the origin O, S, and T. So a circle that goes through T, the origin, S, and T again. So we need to find out the equation of this circle. So that's what we need to know. So there's a point q, there's a normal that goes through it, and it intersects the y and x at T and S, and we need to find the equation of a circle that goes through T, S, and O. So how do we do this? Let us find, we need to first find out this line, right? Equation of this line. So how do we do that? We first find out the derivative of this curve, and then we need to find the perpendicular. So let us do the derivative of this curve. So the curve is this, right? x 15 minus x cube. So let me just write it again like in this form, minus x cube plus 15x. We find this is y. We need to find out the derivative to find out the equation of the perpendicular. So the derivative is minus 3x square plus 15. Okay, and we know the x value, right? The x value is 2, so we input the 2, so we get 2 to the 4 minus 12 plus 15, which is 3. So that's the derivative, and that means the perpendicular's gradient would be minus 1 by 3, since we're just using the m into 3 goes to minus 1, that formula. So the perpendicular's formula, so value is minus 1 by 3. Now we use the line equation. X, we know the x, so minus 2, y equals, so y minus, so we need to find the y value. We input the 2 into this formula, so we get 2, 15 minus 4, that's 9, that's 11 into 22, so 22. So y minus 22 is equals to this. So that's the equation of the perpendicular. So we can further simplify this, multiply by 3, so 3y minus 66 equals to minus x plus 2, or 3y plus x is equals to 68. Okay, so we found out the equation of this line, and this line goes through the x-axis and y-axis, so to create the s and t, right? So so which is s and we'll check that later. Anyway, so we need to find the intercepts of this point, right? So first we set x to 0, so 3y equals to 68, and y is equals to 68 by 3. So that means the x-intercept is 0, 68 by 3. Sorry, the y-intercept. So y-intercept is 68 by 3. 0, 68 by 3. Okay, so we set the y equals to 0 to get the x-intercept, so which is x equals to 68. So that one is 68, 0. So these are the two intercepts. All right, so now we need to find the midpoint of the circle, right? So we simply just add them and divide by 2. Since these are the 2 points, since this is a circle, and we need to find the midpoint of a circle to create the equation, right? So these are the 2 points, so the circle, and since and we know this is the diameter. How do we know this? And that is not a chord, because for a circle, if we have a line like this and it creates a right angle triangle, that is only possible for the diameter to do that. And how do we know right angle triangle? Because this is a right angle triangle, obviously, right? And this is formed by the circle. So this must be a right angle triangle, and the only way that's possible is if this line was the diameter. So this line must be the diameter. So since this is the diameter, the center must be the midpoint. So we simply add these 2 points and find them, use these 2 points, this s and t, to find the midpoint. So we add x68 plus 0 divided by 2, which gets 34, and again 68 by 3 plus 0 by 2, we get 34 by 3. So these two are the midpoints. Okay, we have the midpoint. What else do we need? We need the radius, right? We could find out the distance and divide by 2. That's one thing we could do. Another thing is that notice that we know the midpoint, right? And this origin is 0, 0. We can simply use the equation for this also. So our options are use these 2 points, find the radius, or use this midpoint we got with this point and find the radius, or we could just do with 0, 0, right? Since 0, 0 is easier number to use. So let us do that. The radius formula is this, distance formula basically. So 34 minus 0 square, so not write the 0, just write in a square. So 34 minus 0 whole square plus 34 by 3 minus 0 whole square. So again this thing whole square, and this becomes, so 34 square. So let us do that. 34, so it becomes 16 left 1, 4 to the 12, 13, and 4 to the 12 left 1, 9, 10. Okay, so this one was 12. Okay, it's 4 to the 12 1. Sorry, 4 for the 16 left 1, 4 to the 12. Okay, so this one was 13. All right. So this is 6, 5, 1 1. So 1156 is 34. So this is 1156 plus 1156 by 9. So these are radius. All right, so we can again add these two, so we can multiply this by 9. 9 6 there is 54, left 5, 45, 50. So 50 left 5, 14 left 1, 10. So 10, so 10404. 9 6 is 54. Let me just check that again. 9 6 there is 54, 54, yeah, 54 left 5. 9 is a 40, 40 plus 5 is 50, 55. So 9 plus 14, okay, 9 plus 1 9, okay, yeah, it's correct. So 10404. Then we add 1156. We get 10 left 1 6 and 5 1 1. So we get, so if we add, I'm simply adding these two numbers, so we get 11560 by 9. So this is our radius. All right, so with the midpoint and the radius, let me just erase everything over here. Okay, so our equation would be x minus, so we're in the center, right? So our center was let me just use from here. So 34, x minus 34 whole square plus y minus 34 by 3 whole square equals to this number with the radius square. So 11560 by 9. We are squaring it again, so the square root gets away. So yeah, that is the equation of the line. That is the equation of, sorry, not the line, equation of the circle. So what did we do? We first found out the perpendiculars equation by differentiating this line, this curve, and then finding the equation of the line, and then we found out s and t. We use that to find the midpoint, since we know that this must be the diameter, since this forms a 90-degree triangle. So this, we use a center midpoint formula to find the center, and then we use this point and this point to find the center. This is also possible, these 2 point or these 2 point, not the center, the radius. We use these 2 points to find the radius. It will be also be able to be done with using these two or this any 2 points like this with the center, and then we equate it to we found the radius, so we use the point and the radius to find out the equation of the line. So this question, we have a point W that moves along the curve. So over here the point W moves, so at first it's here, then it just moves along the curve. So and its x coordinate is increasing at a constant of 0.5 per second, 0.5 minutes per second. That means dx by dt is 0.5. Find the rate of change of area of the triangle formed from by the origin O, the point W, and the position of W on the x-axis. So they want a dA by dt. So dA is the area, so rate of change of area, right? So dA by dt they want, and how do and we know dx by dt, so let us equate to dx by dt. And how do we get dA by dt from this? We multiply by dA by dx. So dx is color, so dA by dt. So that's so we need to first, we have this, and we need to find the dA by dx. So let us first understand the area. So it is, the area is formed with origin O. So simply the origin O is one of the points of the triangle. Another is the point W. So W, that's the point that changes every second, right? The point W, and is projection onto the x-axis. So it's simply the x-axis, because if we project it, we simply get the x value, right? So it's just a wordy way of saying the x value. So we can imagine the triangle to be like this, something like this at the beginning, and then it becomes like this, at one point it becomes like this, so, or this again. So every time the projection is simply the x, and this point will be the W. And since it's a triangle, what is the form? So the formula of area will be half into base into height. And what is the base? The base is simply the x, right? So x, and the height is W, which is x 15 minus x square. So this becomes 15x square by 2 minus x to the power 4 by 2, and we need to find dA by dx. So dA by dx is simply the derivative, right? So dA by dx is equals to 15x minus 2x cube, and we need to find the area when x is equal, at the instant when x is equals to 1. So we set x equals to 1 to get the dA by dx at when x equals to 1. So 15 minus 2 and is 13. So 13. So now we replace dx by dt into dA by dx with the values. So these are 0.5 that was given in the question into 13, and we get 6.5. So the rate of change of area at when x equals to 1 is 6.5. So yeah, that's it. And with that, we are finally done with the paper. Good luck for the exam. Thank you.